My name is Michael Larkin. I'm the Managing Director of Tortech Proprietary Limited. Today we're going to have a discovery tour of the testing facilities of Tortech Proprietary Limited, and we'll also discuss a little bit of the design attributes of the transformer with respect to testing. So let's go in and let's have a look. Today we're testing a railway transformer. It's 400 volts in, 400 volts out, delta in, star out. It's 50 kVA. We've got two of them. We're doing temperaturized testing here, we're doing full load testing here, and no load testing in the other laboratory. So here we have a data logger which logs the, it's a 12 channel data logger. It will log the temperatures of the each channel. In addition to that, we have the three-phase watt meter by Yokohama. This meter will measure the currents, the volts, the power factor, the kilowatts. It'll even measure the harmonics. It'll measure every attribute of the transformer. So we have one of those for each rig. Here we supply the transformer from a 60 amp three-phase variac with power factor correction, and the step-down transformers here provide the heavy current for the short circuit test. The idea that we have here is when we're doing temperaturized testing, we actually expect to know what the temperaturized figure will be. So we have a program that calculates the temperature rise of the transformer, and then we make a correction for that in terms of the temperature rise by a special calculation that we have, and we allow then for we have another computer program which actually calculates the effect of the enclosure. This is a stainless steel enclosure, IP56, outdoor rated of course, in stainless steel 316. This is typically what the temperature results look like. This is for the short circuit temperature rise. So that's the plotting of the temperatures on the logger, on the data logger. So that's the short circuit test here and the temperature rise. Now if we move over, we'll go over and have a look at the setup for the no load. So this is the same transformer. These are 3000 amp probes here with special adjustment to be able to measure right down to 1 amp. Again, you've got the same power measuring equipment here, which is the Yokohama CW240. This is supplied here from a smaller variac because it's the no load test. When we're doing shutdown resistance on both tests, we are very particular about the fact that we actually measure the resistance at 10 amps DC. This meter actually not only measures the resistance, whether it be copper or aluminium, it then corrects for that and gives you the temperature automatically at 75 degrees C. This is a micro ammeter. We can measure down to less than 1 micro ohm, and it's very accurate. And it's very fast. If you don't have enough DC current when you're doing the resistance measurements, what will happen is you will actually have an erroneous resistance figure, and that means your temperature rise will not be correct. This meter is actually self-calibrating. We have a self-calibrating piece of equipment with it, and we know that this meter, not only does it measure accurately, but it also measures quickly. And that's important when you're trying to do shutdown resistance. So let's move on and we'll have a look at some of the other equipment. Here we have the vector and the accuracy measuring equipment for the voltage and the turns. We have a printout for this, so the ratiometer will give you the vector and also give you the accuracy of the windings on each tap. Over here, this is our partial discharge measuring equipment. And you'll find that here, this is the controller for the linear amplifier, and this is the the digital partial discharge detector. This allows us to measure discharges down to around about 1 picocoulomb, and we do that on up to 33 kV transformers, and we measure it with very, very good accuracy. The advantage that we have here is that we have coupling capacitors over here when we're doing partial discharge, which not only give us the coupling capacitance and the feedback for the detector, but they also measure the voltage on the output side of on the high voltage side of the transformer. So if we're doing a 33 kV transformer, we'll typically be up around about 66 kV between each coupling capacitor, and we'll be measuring the voltage and the picocoulombs through these coupling capacitors. Over here we've got a 100 kV 10 kVA test transformer, which we can use for testing 33 kV. You need a 70 kV test level, and this transformer can do this quite easily. This floor here is an earth grid floor, which is connected to the outside earth. We have an outside earth which is drilled into the ground to give us an outside grid reference point, which is separate to the switchboard earth, and that's very important for partial discharge testing. Over here is the linear amplifier. The linear amplifier gives us pure sine wave and minimum interference in terms of the supply voltage. It's a pure sine wave voltage with minimum harmonics, and we can do that at any frequency from about 10 hertz up to 400 hertz. So we can adjust the frequency and then increase the voltage on the transformer by doubling the voltage or tripling the voltage by changing the frequency on the linear amplifier. The linear amplifier also comes with a filter, and that's a 3-phase filter which filters any radiated or conducted frequency or interference, and we can minimize that. In addition to that, we can gate the detector, and we can also modify the filtering in the detector if we have any interference problems. We do that before we actually do the partial discharge testing and at the stage of when we do calibration on the test circuit. Over here we have this is an induced set. This will also allow us to test at any frequency, so whether we're testing a 50 hertz, a 60 hertz or a 400 hertz transformer, we can use this piece of equipment. In addition to that, this can also be used for doing the induced testing where you do double induced. We have a number of rigs like this for doing short circuit testing. We have 4 rigs depending on the amount of current, up to probably in excess of 1500 amps we can supply, or we can supply from the high voltage side at 600 or 1000 volts. For a transformer factory mid-size like this, we believe that we have here at Tortech the best testing facilities, and we have also the best design facilities in Australia, and we're more than capable of making up to and including 2.5 MVA here. Thank you.